Hello everyone. Welcome to my channel. In this video, we will discuss a very important topic in the computer world, namely logic in computers. This logic is the basis of how computers work and plays a big role in the decision-making process, data processing, and various other applications. Maybe many of you are wondering, what is logic in a computer? And why is it so important? Well, in this video, we will thoroughly discuss the basic concepts of logic, how this logic is applied in computer systems, to its role in algorithms and programming. Inside the computer, there is a transistor. Transistor functions as a basic component in an electronic circuit, allowing control of electric current flow. They are used in various computer parts, including CPU, memory, and other circuits, to perform calculations and process data. Transistors convert 1 and 0 binary information and enable the underlying logical operations of all computer functions. Transistor is a semiconductor device that functions as an amplifier or switch. The working principle of transistor depends on controlling electric current by using small current or voltage. Bipolar junction transistors, or BJTs, are divided into two groups, namely NPN and PNP. The circuit symbols for NPN and PNP BJTs are as follows. The pins are labeled collector C, base B, and emitter E. The only difference between the NPN and PNP symbols is the direction of the arrow and emitter. The arrow on the NPN points out, and the PNP points in. What is a logic gate? Logic gate is a basic component in a digital logic circuit that is used to perform logic operations on one or more inputs to produce output. Logic gates accept binary signals as 0 and 1 as input and generate binary signals as output based on certain logic function. There are 3 logic gates, including the gate AND. The AND gate symbol is semicircular, with 2 or more inputs on the left side and 1 output on the right side. Usually, the AND symbol has 2 inputs labeled A and B. The operation formula of the AND gate is the same output as a .B. That is, the output from the AND gate will be worth 1 or true if all the inputs are worth 1. If one or both inputs are 0, then the output is 0. The AND gate truth table shows all possible input combinations and results. If both inputs, A and B, are 0, then the output is 0. If one of the inputs is worth 1 while the other is 0, the output remains 0. If both inputs are worth 1, then the output is 1. Next, there is a NOT gate. The NOT gate symbol is a small triangle with a small circle at the end of the output, which indicates that the output is the opposite of the input. A triangle indicates the operation of logic, and a small circle indicates an inversion or inversion of a value. The operation formula of the NOT gate is that the output is equal to the inverse of the input. This means that the output from the NOT gate is the opposite of the input. If the input is 1 or true, then the output will be 0 or false, and vice versa. The NOT gate truth table shows all possible input values and results. If input A is 0, then the output is 1. If input A is 1, then the output is 0. There is a gate OR. The OR gate symbol is curved with 2 or more inputs on the left side and 1 output on the right side. The operation formula for the OR gate is the same output as A plus B. The output from the OR gate will be worth 1, or true, if one or both inputs are worth 1. The output will only be 0 if all inputs are 0. The OR gate truth table shows all possible combinations of inputs and results. If both inputs, A and B, are 0, then the output is 0. If one or both inputs are worth 1, the output is 1.